And now I want to introduce our final speaker for this block. So we heard a little bit about GraphQL, about Storybook, about state management, and now we're going to hear about error handling. Error handling for a better UX. That's the topic of the talk. And Elad Semach from Viva Systems is going to give us the talk. Elad is a software engineer at Viva from Toronto, Canada. Elad is the UI lead for Safety AI. Safety AI is a cloud-based product that enables companies in pharmacovigilance to automate processes using artificial intelligence. Super interesting. And he's very passionate about AI, React, the entire JavaScript ecosystem, web architecture, and new technologies. So Elad, how are you today?
Good, thank you. How are you?
I'm great. Were you? You're talking from Toronto right now?
Toronto, yes. Relatively sunny Toronto.
Oh, that's nice.
Yeah. Cool. So yeah, thank you for the introduction. Yeah, I guess I'll start the presentation.
Yeah, whenever you're ready.
Cool.
Okay, so take it away, Elad.
Yeah, sorry. Just a second. Okay. Can you see my screen? All the slides? Okay. All right. So I will start. Oh yeah, sorry. Like there was just like a bit of a delay, but yeah, I can see that you can see the slide, so all is good. Great, cool. So hi everyone. My name is Elad Temach, and I'm a software developer at Viva Systems in Toronto, Canada. Viva Systems provides cloud-based products for the global life sciences industry, and I currently work there as the lead UI developer for the Safety AI product. Today I'll be talking about error handling in React for a better UX and show how we use that strategy to log our production errors, which enabled us to be more proactive when handling UI issues. We have a lot to cover, so let's get started. The first thing you might be asking yourself is, why should I care about UI error handling? You might think that your company is pretty thorough when it comes to testing before shipping to production, and that might be true. In an ideal world, we would expect to see our app working smoothly all of the time, right? But still, unfortunately, we do not live in an ideal world, and so it's pretty much inevitable that we will sometimes encounter unexpected runtime errors in our applications. So I'm just going to be using this application as an example. It's a very small application, classic to-do list. And let's say we have this application. It's, again, pretty simple, pretty straightforward. You can see there is the input field at the top where I can type in a task to do. And then when I click on add, it gets added to the list. And for each task, I can mark it as done if I click on the green check mark, or I can remove it from the list if I click on the red X icon. So again, pretty simple stuff. I have some pretty common tasks here, like who doesn't need milk or who doesn't need to finish a React course. I guess Rex, that's debatable. Not sure if everyone here has a dog. But anyway, let's imagine that each of these rows is a component, right? So each of these tasks is its own component, and that component is called to-do. So the component will look something like this. Essentially, we will be passing an array of objects to that component, and we're going to be rendering, let's say if we have like 3 tasks, it's going to be an array of 3 to-do components, 3 to-do objects, right? So the to-do object has 2 properties. It has the isDone property, which is a Boolean, indicating if a to-do task is done, of course, true or false. And then we have the text property, which represents the actual task that needs to be completed. And then if you look at the code snippet just below it, we can see that if we add like a style of text declaration, so we kind of like strike the task with the line through. if the to-do dot is done is true. If not, we don't really style it in any particular way, and we display the text. Below that, we have a div container with two button elements, and those buttons, like you saw in the previous slide, those are basically for marking a to-do task as completed. And we have like event handlers for those, which are not really relevant for this, so I'm not going to show them. But essentially, when you click on it, it marks a task as to do, and when you click on the X button, it removes a to-do task from the list. So again, I'm reiterating that although the to-do is a component that you can see in the snippet here, it's also an object. Above with the is done and with the text properties. And that's important to remember for the next slide, because what we're going to be doing is breaking some stuff. So let's say we add this code to our to-do component. So it essentially says that if the to-do item index in the to-do objects array is equal or greater than 3, meaning it's the fourth to-do task that we add, or greater than 4, so the fourth task, but like that's of course positioned in the third index. If that's the case, we call the to-do function. Now, obviously, this is going to break. It's going to fail. Why? Because to-do is not a function. Like we saw in the previous slide, to-do is an object that it has to. If we add this code snippet where we call to-do, it's going to fail with the classic type error that you're probably familiar with, saying it's not a function, you can't call it, right? So what will we see actually when this happens, when we already have a list of 3 items, and then we want to add a new one, right? That's going to be index number 3 in the array in this case, right? So what's going to happen? Well, if we're in development mode, this is what we're going to see. In the case of this application, this small application, we are using Create React App, and this is what we'll see if we're in development mode. And Create React App has a tool called React Overlay Error, which shows error messages from the console as an overlay over your application, so you can easily check the stack trace and debug the error. So as you can see here, it gives us the error, gives us the stack trace and all that, so we can debug it when we're in development mode. However, this will not show up in production. It's just a development tool duplicating the normal browser dev console. And again, as you can see, if you look at the very, very, very bottom of this page, it says this screen is visible only in development. It will not appear if the app crashes in production. And you can hide this screen when you use Create React App. You can hide this screen if you press on the escape keyboard button, or if you click at the X at the top right corner. And then you will get what you'd actually see in production, which is this. Now, if all you're seeing is white right now, that's because that's exactly what your users will see in production when this error happens. Our application will simply crash because of this error. And it's only if you open the DevTools console in your browser, for example, in Chrome, that you would see the error that we previously saw, right? So like this is what you would see in the developer console. And this actually indicates what the issue is. There's a type error, like we mentioned before, indicating that to-do is not a function. So we can't call it, right? Because again, as we noted before, it's an object. But as far as your users are concerned, right, they probably don't know anything about the dev, dev tools, the dev console. They don't know, like, even if they did, they would open it. Like, what is to-do function? Like, most odds are that they're not familiar with React or JavaScript. They would not be able to understand what the issue is, and they would just see a blank white screen. So they would not know what happened, and probably they won't even care what happened or why it happened. Maybe they lost some unsaved work they might have had on the page before the application crashed. And again, they don't know why or what happened, but they're probably mad, right? Because the web application crashed. So we need to ask ourselves, does it make sense that one small error in one small component in our entire application will crash the whole thing and give our users a really bad experience? Now, of course not, right? So we need our React application to be fault tolerant. Now, what is fault tolerance? So that is the property that enables the system to continue operating properly in the event of the failure of some of its components, right? So in my experience, fault tolerance is often overlooked and undervalued in web applications. I've seen it in a few companies where they might have like hundreds of units and automation tests that provide confidence that things probably won't break. But then there is the question of what happens when some inevitable failure happens, something unexpected, because that could happen, right? So this is why we need to make our React application fault tolerant. Ideally, our React application would continue to operate and it won't crash in the event that one of its components crashes. So how do we make our app fault tolerant? With error boundaries. So an error boundary is a class component, and a class component becomes an error boundary if it defines either or both of the lifecycle methods, static, get derived state from error, or component did catch. And that simple definition is taken from the React official documentation. So error boundaries were introduced in React 16 as a way to catch and handle JavaScript errors that occur in the UI parts of our app. So all you need to do to create this error boundary, all you need to do is create this error boundary and wrap your components with it. And there are two things to note here. Firstly, only a class component can be used as an error boundary. Even if you're writing all of your components as functional components, you still have to make use of a class component if you want to have an error boundary. The second thing is that the error boundary itself, that class component, has to define either one or both of static get derived state from error or the component did catch. Which one you define, or if you define both, really depends on what you want to accomplish with your error boundary and your error handling strategy. So this is an example for what an error boundary component might look like. And you can see there are like two things here that are, well, actually three that are worth mentioning. So the first one is the get derived state from error. That's the first method that we, first lifecycle method that we defined after the constructor. And that is a lifecycle method which is invoked after an error has been thrown by a descendant component. So that essentially means it is thrown if you have a component that's being wrapped with this error boundary component. It receives the error, so you can see in the function argument it has the error, and this is the error that was thrown, and it should return a value to update the state. So in this case, you can see that at the beginning in the constructor, we set our state with one property, has error, and that's a Boolean. It could either be false or true. And then in the get derived state from error lifecycle method, we return what we want the state to be. So again, just because the expected return value of this method is a value that should reflect the state, like that's going to be the updated value of the state, you don't really need to update the state like you normally would in class components, but just return an object, and that in turn is going to be the new value of the state. So in this case, because we received an error, we set the has error to true. So why does that matter? Well, if you look down into the render method, you see that we check when we call the render if this dot state dot has error is true. If it is true, we render a fallback UI. Now, a fallback UI can be literally anything that you want, any valid JSX syntax, component, element, whatever you want can be returned. Just treat it as if it would be like any other React component. In this case, we just want to keep it pretty simple, so we're returning an h1 element with the text that something went wrong, right? And if there is no error, so for example, if the get derived state from error was not triggered because everything is working fine, we don't have any errors, then we just return in the render method the this.props.children. In this case, this refers to all the components that you're wrapping, that are being wrapped within this error boundary component. So those are like the first two things. The third one is the component did catch. And this component did catch lifecycle method. Again, you don't have to declare it like we saw in the definition of an error boundary in the previous slide, but it will be invoked as well if you define it in the commit phase. And it receives two parameters, the error, which is the same error that the get derived state from error received, and error info. And error info is the interesting one because that is the stack trace of the error. So if you get the error itself, it might not necessarily help you because you won't know where it came from, right? But if you get the error info, if you get the stack trace and you log it, like in this case, you see, in this case, there is a call here to log error to my service. That essentially means we're logging it to some logging server. Then once you have that logged, you can debug it easily. All right. So one thing that's important to mention, or I guess a few things, error boundary in its nature, it catches error in some places, but not in others. So it does catch errors in lifecycle methods, if we're talking about class components, in render methods, in hooks like useEffect, and in component logic, but that has some limitations. Now, what are those limitations? Well, if you have some code in event handlers, anything that has to do with asynchronous code, like making API calls, if your application is being rendered on the server, or if there's an error with the error boundary component itself, all of these will not be caught under the error boundary component that we just introduced. So those things are important to keep in mind. There is a way around it, around some of these that I'll be briefly mentioning later on. But for this basic idea of what an error boundary, what a traditional error boundary is, just keep that in mind. Now, also for this application, for logging the errors, we'll be using Sentry. Sentry, for those of you who are not familiar with it, it's an open source error tracking that helps developers monitor and fix app errors in real time. It has support for JavaScript, React, Node, Python, PHP, Ruby, Java, like a lot of programming languages. And it provides a very organized and user-friendly dashboard where you could view and filter all of your app errors. Get notifications about them, view device information, like which device and browser your user was using when that error was triggered, and a bunch of other stuff. Of course, you can use whichever login service you want. Sentry is just an example. So going back to the error boundary for a second, in our case, this is how we're going to be using it. We're going to be wrapping our to-do component with the error boundary. So as you can see just above it, above the card body, above the card component, we have this to-dos array, which consists of to-do objects, just like we noted before, right? To-do objects have two properties, is done and text. And we essentially map each to-do component, each to-do object to its own card body, and then error boundary, and then to-do component. Now, the reason why we're not wrapping the card itself with an error boundary is because we still want to display some sort of like a task container, and you'll see a screenshot of this in a couple of slides. So we still want to render something, but instead of like rendering the task itself, like the task text with the check mark and X buttons, we're going to be rendering a fallback UI if there is an error. So this is the error boundary that we created for this. This is what's wrapping the to-do component. As you can see, there is the get derived state from error, similar to the other example where we define as error as true. And then there is the component did catch where we log our errors. And actually, like this dot set state here, like the call is not really necessary, so you can disregard that. But what matters is that in the component did catch, we do the logging to Sentry. We log the error itself and the stack trace that is under the info. And then in the get derived state from error, that's where we set the state to has error equal to true. And then in the render method, again, just like in the example, we check if there is an error. We're going to be rendering an H2 element and indicating something went wrong. If not, we're going to be returning this.props.children, and just quickly going back to the previous slide, that essentially, in this case, children of the error boundary, like you can see, has one child, which is the to-do component. So you might ask yourself, okay, like, what is the difference between get derived state from error and component did catch? Like, why can't we just use one? Why do we need both? Like, what's happening here, right? So I'll try to like clear it up a bit. So get derived state from error, that's like a lifecycle method like we mentioned previously. It's invoked after an error has been thrown by a component, and it receives the error that was thrown as a parameter, and it should return a value to update the state, right? Like all of that we've mentioned before. Now, the thing is, it is called during the render phase, right? So you can't do any side effects here. That means that you cannot do any logging. If the only thing that you wanted to do was just render a fallback UI and you don't care about logging, you don't want to log anything, that's fine. You don't need component did catch. You can just use get derived state from error, set has error to true. Then in the render method, you can check the has error state property and render based on that. But again, because this lifecycle method is triggered upon render, you cannot execute side effects here, such as, I don't know, fetching from APIs or calling a logging service or like anything of that sort. You cannot do that here. Where you can do that is in the component did catch. This is a commit phase lifecycle method, so side effects are permitted here. So this is where we can actually call the logging server and log the error along with the error info. So also in the React official documentation, it says that in the event of an error, you can render a fallback UI with component did catch by calling set state. Because again, similar to like how we return has error equal to true in the get derived state from error, we could do the same thing in component did catch, right? But it is noted in the React official documentation that this will be deprecated in a future release. So really, you should be using get derived state from error to handle fallback UI rendering, just like we're doing here. So bringing this into action, we can see that we have like the three items from before, but then once we click on add, that is again going to be the fourth item we're adding. And if you remember, the way we broke things was saying if it's index equal or greater than 3, then we are gonna call to do function, which is gonna fail, of course. It's a type error, but we're gonna do it anyway now because now we're safe, we're using an error boundary. So once we click on add, instead of having a blank white screen, we get like another card component here, but instead of a task, of course, we're seeing something went wrong. So we're not seeing the test. You know, if you see on the left image, there is the test text that we put in the add to do input field, but we are not seeing it because of the error, and that's why we're seeing the something went wrong, because that's coming from the error boundary itself. That's the fallback UI that we're introducing. So that's cool. Our app didn't crash. Users can still mark, you know, like they can still interact with the existing other 3 tasks. They can mark them as done. They can remove them. Everything is great. Our app is still working, although something failed. And of course, we will have to fix that. So for fixing that, we'll have to go to our logging service, to Sentry in this case. And what's happening here is that this is just a screenshot from the Sentry dashboard. And as you can see, we see that there was a type error here saying to do is not a function. That's the error itself. And then because we also logged the stack trace, then we see that under the error info. So here we can clearly see where this happened. And yeah, from there we could just continue and debug our application and fix it without, you know, like even before even like one of our users have a chance to file an IT ticket because something happened to the application. And this is pretty much it for the UI error handling tracking. Our app didn't crash because something went wrong in one component. And again, now we have the logs in Sentry, which we'll be notified about, so we can fix the issue, and all is good. So finally, I just want to touch about a question that you might have, which is where to use error boundary. So, or in other terms, I guess, which components in your app need to be wrapped with an error boundary. So the only thing, it's definitely it's a case-by-case basis, but definitely if we just just look at the two extremes, for example. So you should not, on one extreme, you should not be wrapping your whole app in one error boundary, right? Because then if a little thing fails in your application, everything is going to fail, and you're going to see one big UI fallback, right? So it doesn't make sense to wrap your entire application with one error boundary. So that's one extreme. But then taking it to the other extreme, you should also not wrap every single component you have with an error boundary. And I'll show an example, which I think will make sense. I'll use LinkedIn as an example. I'm sure you're all familiar with it. This is the main page of LinkedIn with the feed and all of the other features. And if we had to divide all these features, all this, I guess this page, if we have to break it down to potential React components, right? It would probably look something like this. So we would have in the blue, the top left, it would be kind of the profile summary. Then below it in the gray would be your communities, groups, all that information. Then in purple, where you can share a post. The yellow would be the post itself that you have on your feed. Then on the green, just news and everything from today. And on the red below it, suggestions regarding who to follow on LinkedIn. And of course, there's probably a few other components like the footer and the nav bar and and all that, but we'll just stick with that just for now. So again, going back to the first extreme, it would not make sense to wrap this entire LinkedIn main page with an error boundary because, again, let's say one component fails, let's say the news, for some reason, the green one, we could not fetch today's news, something failed. We'd have to render a fallback UI only here. But if this failure causes the whole app to render one big fallback UI, it doesn't make sense, right? I mean, if we could not fetch today's news on LinkedIn, it does not make sense that everything else will also stop functioning, and you will not be able to interact with any other feature, right, on the main feed. So this is one extreme, and then taking it to the other extreme where we said, okay, we also don't want to wrap every single component with error boundary, right? So what do I mean by that? We'll just focus on the red component, which is the suggestions for who to follow on LinkedIn. So if we just look at it, we can maybe imagine that there is this one line, every person or every company that you're suggested to follow is one component, right? And then under that component, let's say you have two components. Maybe that's the case, maybe it isn't, but let's just say that's the case. So you have two components. One of them is the green one, which is the follow button, and the other one is the red one, which is the actual user information that you should follow. So if we use error boundary to wrap the green follow component, and then we use another error boundary to wrap the red user information, what do you think would happen in case there is a failure, right? So like we saw earlier, we will be rendering a fallback UI. Now, let's just take the follow button, for example. If this fails for some reason and we render a fallback UI instead of the green follow button, then all we'll be seeing is the red part, right? The Ryan Holmes in this case. And okay, so for me as a user on LinkedIn, I see that I was like, cool, I mean, there's this person on LinkedIn, but I can't do anything, right? I can't follow him because the button is gone and there was an error. So it doesn't really make sense, why should I show this user information if I can't follow him, right? It does not make sense. And then on the flip side, if there is an error with the user information, the red part, the red component, and this fails to render, we show a fallback UI. In this case, I only have a follow button, which also doesn't make sense because, okay, let's say I click on that follow button, who am I going to follow? I have no idea, right? So in this case, it would probably make sense to just wrap this whole component. So both of these small components, the component that's marked by this red outline, wrap this component with an error boundary, because in that case, if one of these two green or red fails, everything fails. It just does not make sense to show one without the other. So this is another example just to kind of like better guide you regarding where to put the error boundary. Last thing before we wrap up, I did promise that I'll give you kind of like a bonus, like a way to bypass the traditional error boundary limitations. So this is like a pretty well-known library called React Error Boundary. Pretty well-known package. It has, I think, over 600,000 downloads per week, I think. Yeah, in case you're not familiar with it, I'm just going to briefly mention it. It gives you a wrapper you can put around your components, so you don't really need to write your own error boundary class like we saw before, right? So that alone could be like maybe an appealing feature for some people. But the two other nice features of this package is that first, it can catch errors where traditional error boundaries cannot. So if you remember, we said previously that traditional error boundaries cannot catch errors in event handlers or asynchronous code like API calls. With this library, you'd be able to do that. And then the second one, which I found to be really cool, is that you could provide a function to the onReset prop, like you can see in this example here. And that's gonna essentially reset the state of your application once an error has happened to try and avoid further errors. So in this case, we have this component here called component that may error. We wrap it with error boundary, which is imported from that React error boundary package. And then we provide, of course, the fallback component and then onReset. So the error fallback component, just like right above it, that's our Fallback Ui, right? It's like very similar to what we saw earlier. It says something went wrong, displays the error message. But then the nice thing about it is that you can call onReset. You can provide this onReset prop function, and that essentially is going to reset the state of your app so the error maybe doesn't happen again. So in this case, in this example, there's just like this button that's introduced. It says try again, and when you click on it, it calls a reset function. So for example, let's say if you use, I don't know, like Redux, for example, and you know that there is like a state of your application in Redux that should not have any values that may lead into errors. So once you click on that, essentially everything in your app resets to have that safe state. Right, so that's like a pretty cool feature, I think. So definitely recommended to consider this option as well over using the traditional error boundary. But again, it all really just depends on your needs. But it's good to be aware of the options. Cool. So yeah, that's pretty much it. To sum up in this presentation, we saw what error boundaries were, how to implement them, and when to use them. And error boundaries really help us at Viva Systems to catch UI errors, log them, and present a fallback UI to the user, overall providing a much better user experience than what we used to have, as well as giving us visibility to the UI errors encountered in our production environment so we can fix them right away as they appear. And yeah, with that, I would like to thank you all for listening and enjoy the rest of the conference.
Super. Thank you so much for this talk. Really interesting topic, and I think one that everyone needs to think about when they're writing an application. I imagine that the decision on where to put the error boundaries is a joint decision between the developers and the product, right? It depends not only on how the product is divided, but also on how the code is divided.
Yeah, exactly. Right? Yeah.
Would you recommend, for example, putting one error boundary on top just to catch all the errors that are not caught in like small deeper boundaries? Do you have something like that?
So you mean like one error boundary like around the entire app, or?
Yeah, just in case that there's some error in a component that you didn't foresee and you didn't get caught.
Yeah, so that's just like one thing that I touched about like in the presentation, is that like the problem with that is that like if something happens, then your app will crash, right? Because like in the error boundary, you need to display a fallback UI. So it makes like, if you have like a very like super small application, like a counter, like for example, then yeah, like, it's super small. But if you have like a big one like LinkedIn, that I just used as an example, then yeah, there are like so many features, and if you just use one error boundary to wrap everything, and once an error happens somewhere in your application, you just say, okay, an error happened, all features are disabled. That kind of like, it's kind of sucks for the user that they can't really do anything. But yeah, like I would definitely recommend kind of like trying and isolate like certain components or like certain features within your application, and then decide based on that.
So in Viva, when you develop a new feature or a new sub-component or subtree, you always develop an error boundary for that? It's like it's part of the spec, it's part of the PR?
Yeah, for our team, it is like usually we work with the product team, because we also need to get like a design. That's probably kind of like that would be a decision that would fall under like a product manager or something like that, to say, okay, like how do we communicate the error to the user in like a meaningful way, and yeah, like how do we follow up on that? But like we work very closely with the product team, because I think there's like another big part of it which was not discussed here. This was like very technical. But then there is like another part of like, okay, let's say you render a fallback UI. What's going to be in that fallback UI? Like how should you communicate the error to your users, and that don't have any technical background? Then should you tell them what happened? Should you not tell them what happened? Should you give them maybe like a suggestion on like what to do? Like all that type of stuff is like, yeah, it's like a whole other topic.
So you showed error boundary as a class, right? Because it's something that's currently only class to support. So does it have a parallel for function components?
Yeah, so for functional components, yeah, like there is no way that you can create an error boundary as a functional component. You can either use the class one, like I presented, or you can use the package. In which case, you're not really creating it yourself. You're just getting it from someplace. So like, I guess like in that case, it doesn't really matter. Yeah.
Yeah, so you can't really define like an error boundary as a function component.
Yeah, it's just because the definition of like the in order for like a component to qualify as an error boundary, it has to implement those two lifecycle methods that we discussed. So although maybe there is like some hook equivalent right now, according to the React API, those have to be declared, and of course you can declare lifecycle methods and functional components. So yeah.
So is it different for you thinking about error boundaries when you have a lot of lazy loading components? Since you have the fallback of the suspense, right, which is similar. So how do you combine both of them?
Yeah, so like yeah, this is like an interesting question. I think that they're not like mutually exclusive in my opinion, because when you lazy load components, then sure, like you show that fallback UI while the data is being loaded, but what happens if there is an error, right? Like that's kind of like when you need to think about, and yeah, like, I mean, technically while you fetch the data, you can say, oh, if it failed loading for some reason, display this UI. Sure, that could definitely work. You don't have to use error boundaries there. But what happens if you fetch the data, everything is working, but then the user does something that crashes this component that was just lazy loaded? Like then what are you gonna do, right? So I think like in that case, both of them can be combined.
Okay, by the way, does error boundary work even for portal components? So if you render inside a portal?
That's a good question. Yeah, like to be honest, like I'm not sure. Like I've never tried that with portals. But yeah, that's a really good question. I think that like it should work according to, I don't know, just like think about portals, because portals are like technically still, as far as like React are concerned, like even if you have a portal defined, then it's still like in the React code, like you're placing it inside somewhere. And as far as React is concerned, the portal is not a portal. Like it's still a code within a code, but it's only when it renders it to the DOM when it, like puts it like above everything else, or like whenever you declared it to be, right? So I've never tried it personally, so I'm not gonna say I'm sure 100%. But if I had to guess, I would say that yeah, it should probably work with portals. Might be wrong though.
Maybe final question specifically about error boundaries before we head into the Q&A. How do you log the errors if you don't build your code with source maps in production?
Yeah, that's also a good question. So yeah, like I think there's like the source maps, of course. People like there's like also an argument to be made of like, okay, whether it's like safe to ship source maps in your production code or not. Some people are like don't care. Some people say like I don't want people to steal my code. For us, like at Viva, like our API, our applications are not like public facing. Like we have specific customers, and each customer has their own private access to a cloud application. So in that case, like you can just host your source maps on VPN or something like that, or like use some sort of like authentication that only people who are accessing using the VPN or like only authenticated users could then access the source map. Like you can host the source map on like a different server, and then just fetch it if their if their security criteria are met.
Great. Again, thank you very much, Elad. It was super interesting. And Iswan, don't go anywhere because you're joining us for the QA panels in a few minutes.
Yeah.